What is everything made of? Atoms, right? The building blocks of everything you've ever touched, tasted, or tripped over. But atoms aren't the end of the story. They're more like the Lego sets of the universe. Snap them apart, and you'll find smaller pieces inside. Electrons in a cloud around the nucleus, and protons and neutrons chilling in the middle. But here's the twist. Even those protons and neutrons aren't fundamental. They're made of something even tinier. Enter quarks. Quarks are the short kings of the subatomic world. They're not just small, they're so small that calling them small feels like calling the ocean a bit wet. They're the foundation stones of matter, the things that make you. Without quarks, there's no bread, no YouTube, no you. So how many types of quarks are there? 6. And because physicists like to give things names that sound like they were invented during a sleep-deprived Dungeons & Dragons session, they're called up, down, charm, strange, top, and bottom. No, I'm not making that up. That's the actual scientific terminology. Somewhere out there, a Nobel Prize winner had to say strange quark with a straight face. Now, here's how they work. Protons are made of 2 up quarks and 1 down quark. Neutrons, 2 downs and 1 up. That's it. That's the recipe for the core of every atom in your body. Mix and match these quarks, and suddenly you've got the ingredients for stars, planets, and your favorite overpriced coffee. But quarks don't like to be alone. They're clingy. They're held together by something called the strong force, which is basically the universe's ultimate glue. And the carriers of this glue are particles called gluons. Yes, gluons, as in glue. Physicists aren't always subtle. Here's the wild part. Quarks are never found solo. You can't just pluck one out and put it under a microscope. They're always bound together in groups like squads that refuse to split up. This is called confinement. Try to pull them apart, and the universe just makes more quarks. It's like trying to delete an app, and instead your phone installs 2 more. And if you're wondering how we even know quarks exist if we can't see them, the answer is particle accelerators. Giant machines like the Large Hadron Collider smash particles together at ridiculous speeds, and from the debris, we can infer what's inside. It's like reverse engineering a car by crashing it into a wall and studying the wreckage. Now, let's zoom out. Why does this matter? Because quarks are literally the reason matter exists at all. After the Big Bang, the universe was a chaotic soup of energy and particles. Quarks paired up with gluons, formed protons and neutrons, and eventually gave rise to atoms. Atoms formed molecules. Molecules formed stars. Stars forged heavier elements. And billions of years later, here you are, scrolling on your phone, made of quarks that have been around since the dawn of time. But there's another layer of weirdness. Quarks don't just have mass and electric charge, they also have something called color charge. Don't picture red, green, and blue crayons though. It's a quantum label physicists use to describe how quarks interact. The rule is that quarks combine in ways that cancel out their colors. It's like the universe has a strict dress code and quarks never break it. So, what is everything made of? At the deepest level we currently understand, quarks, gluons, and a handful of other fundamental particles. That's the bedrock. Everything else, your dog, your sneakers, your Spotify playlist, is just a remix of these tiny, stubborn building blocks. Every time you take a breath, every time you laugh, every time you binge watch a show at 3 a.m., you're basically a living, breathing cloud of quarks doing their thing, and that's pretty amazing. Glue your mouse to that button like a gluon holding quarks together. Subscribe so you never miss another weekly dose of everyday sorcery.